We now give the floor to Professor Bruno Siciliano. I think he's coming very happy because he was just playing a soccer play with Maradona, thanks to art dive experience that you can maybe experience also in the back when we finish the inspiring session, thanks to Olimente. So thanks to the Consul General, she already gave an introduction to Professor Bruno Siciliano, so I just leave in the floor. Thank you.
Hello, good morning everybody, and thanks very much indeed to the Fondazione Morra Greco and the colleagues of University of Naples Federico II for the kind invitation, as well as to Mrs. Tracy, the Consul of the United States, for the nice intro. Actually, I'm humbly flattered. Can you hear me? Okay, that's much better. I'm humbly flattered to give this talk after such inspiring words by one of my mates, Jeffrey Schnapp. I was chatting with him before the event, and this is the second time I give a talk in this beautiful, gorgeous location. And I always believe, as a Napolitan, in the course of fate of the history, because the previous event, which was held here, was with Rector Gaetano Manfredi, and this was an event for the ERC grantees. ERC is the European Research Council, which is like the most prestigious institution in Europe granting research. And at that time, I got an advanced grant on robot dynamic manipulation, the project Rodiman, and you will see Rodiman in a video afterwards. And as a matter of fact, I think I'm breaching a sort of communication embargo until noon of today, but please, take it very confidentially. But at 12 today, the president of ERC will announce the new Synergy grantees. And I was one of the project about the robotized colonoscopy. So, I mean, it's this fact, this will be a huge project for... And I believe it's the first Synergy grant of a faculty at University of Federico II. So I'm going to speak about robots and humans, and I was undecided how to break the ice, but since we are talking about museums, we're talking about art, I dare to take you to, not too far from here, to MAN, the National Archaeological Museum of Napoli, which was inspiring my MOOC course of robotics. I'm also active on web learning education, because we are in a global world, and I do believe into this kind of media. So let me... Welcome to Napoli, a city well known for its rich history, art, culture, architecture, music, and gastronomy. Let me take you on a virtual tour to MAN, the National Archaeological Museum of Naples. And this is one of the masterpieces of the museum, the Farnese Hercules. This massive marble statue depicts a muscular Hercules leaning on his club. He's just performed one of the last of the 12 labors, which is suggested by the apples of the Hesperides he holds behind his back. So this is a ball, like one of Hercules' apples, and I'm going to place the ball at the tip of a slender stick. And I'm trying to hold the stick from the bottom by achieving a sort of dynamic balance. That's quite tough. And this is beyond the capabilities of an average human. Only a juggler can succeed in performing this task. Maybe a robot manipulator can likewise perform this task. To successfully perform this kind of advanced manipulation task, we need sensory motor skills beyond those of the humans. So I'm going to take you to virtually on a tour in Prisma Lab at University of Naples Federico II. My student has just released the stick, and the robot is successful in holding the stick from the bottom and stabilizing this dynamically. So this was a trailer for this course, And of course, I get a lot of excitement from my students to just do a master's and also a PhD in my team, at the Prisma team in the Department of Electrical Engineering and Information Technology. But what is robotics? Robotics is commonly defined in our community as the intelligent connection of perception to action. So in the very end, it's our human life. This is the well-known feedback principle, which regulates all the functions, all the acts that we exert, we act as humans. As you see, we have three subsystems, three essential components for a system to be a robotic system. We have the perception, the sensors. If I'm thirsty, I just localize the glass of water, then I touch, so I have some sort of haptical feedback. Then I elaborate the signals, this data, in a kind of intelligent way, and then I act the motion with some sort of actuation. Now, often in the media, we read about robotics and AI and robotics. And often, if you read any article in the media about AI, the iconic image of AI is a humanoid, is a brain, is a robot. So there's a sort of tight connection with AI. What is AI? In a very broad sense, we can define AI as computers mimicking the functions and the logics of the human mind. So we find the same ingredient, intelligence, which is at the basis of the definition of robotics. But also, we find perception. If you take Alexa, Siri, or even ChatGPT, you just share some visual and vocal data. So it's the importance of the senses to make use of the artificial intelligence. And this is one such example of cross-field contamination outside the boundaries of robotics. I was born in '59, which was the year the first industrial robot was made, and I've been in robotics 40 years. I'm convinced that any further progress in our field will not be in our community, but at the crossroads with other disciplines like neurosciences, like visual prototyping, like machine learning, like science philosophy, and so forth. And speaking about this contamination with neurosciences, our friends from neurosciences did carry out a very interesting study. I think it was published like 3 or 4 years ago. This is this called cortical homunculus. What is the cortical homunculus? It's a sort of parasitic view of the importance of the sensor for the human, and the size of the sensory organ is proportional to this importance. So this homunculus has big hands. So you might think that the most important sense is a vision, but actually it's touch. A visually impaired person conducts a decent life by touching, by exploring everything. And this sort of pattern that touch is so important as a kind of deep roots back to the Greek philosophers. This Aristotle was convinced of the centrality, of the superiority of the human, and he believed that human develops his intelligence in such a way that then allows them to interact with the world, just to explore the world through their senses. Anaxagoras was of the opposite theory. I used to say that Anaxagoras was the theory of the child. A child, in the first 3 months of their life, children, they explore the world by touching everything. They grasp the objects and they bring the object to their mouths. Why do they do this? Well, the parents get worried because they're afraid that they will eat all the object. But actually, this action is bringing the object to the soul, to the brain, to the very central heart of a child. So Anaxagoras was for the child, and he believed that human being develops their intelligence through the exploration of the world, with the sense of touch. And this is a very important concept, which in the field of AI and robotics is known as embodiment. So not only is there a sort of neuronal intelligence, but there is also a sort of physical intelligence, which is in the shape of the hand, the fingers, the phalanxes, that allows the child to develop their greater intelligence in the second part, like after 9 months, 1 year, 2 years, and so forth. So we have here a sort of crossroads of converging technologies between AI and robotics. And other than losing in a sort of scientific dispute about whether it's more important robotics or AI. Of course, I'm a roboticist and I believe in AI as enabling technology, but if you speak to the AI gurus, they look at robotics one of the N applications of artificial intelligence. Actually, the challenge is at the intersection of robotics and AI, and physical AI is much harder. And I also want to share this feeling of being sensible to the correct use of AI in robotics, because a blind use of AI in robotics can be potentially very dangerous. And together with a friend and colleague, Antonio Bicchi from University of Pisa, a couple of years ago, we published a comment in Nature Italy, and actually we were explaining how we are living a sort of transition from after 2-3 decades of the development of interaction of information, this was Freudian, of information technology, we're moving towards interaction technology. And the acronym is intentionally made of three letters to disambiguate, to distinguish from information technology, but also to stress the importance of the physical action for the development of the future robots and machines. So going deep to just studying the robots and humans, of course, I was fascinated by my readings of Asimov books about science fiction, about cybernetics, when I was a teenager. But also, I was influenced by reading books by Italo Calvino. Actually, this year, I think, is 1 century since his birth. And there's a very nice book, which is American Lessons, Lezioni Americane, and this is an excerpt from that book, in which, if you think about a robot, the imagination is unavoidably of anthropomorphic nature. So here, when we want to understand what robots and humans are, this is a virtuous circle between those people that study life, like the neuroscientists, like the expert of biomechanics, like the psychologist, and us, ourselves, the technology makers, that we develop the mechanical system, the intelligence system, and the perceptual system, the sensory system. So the people studying life look at robotics as one lab, as one gym, to validate their theories, where we get inspiration from life sciences. And that's why now in the new course of automation and robotics, we have biomimetics, biomimicry, and bionics, and we break the conventional paradigm of designing system in a sort of traditional way, with the mechanical design, like very heavy systems and so forth. And so we have to look forward to the future in which robots will become social other than solitary. Now, the word robot derived from the Slav robota, which means subordinate work. So robots were introduced to replace the humans in a sort of dangerous or maybe tiring or frustrating jobs. But the new dimension is to have a robot as a companion. So not only will they replace humans in dangerous tasks, but also they will accompany humans, and not only in the professional settings, but also in the life scenarios, like in our homes, in our hospitals, in our farms, and even on freeways. According to the definition of robotics, an autonomous car is by all means a robot. Now, if we speak about the anthropomorphism concept of Italo Calvino, I also want to spend a few seconds about the physical appearance of a robot and the role of aesthetics. I like this book by Matteo Cris. This is design between human and machine. So that's why, from a design viewpoint, we need the designers to make robots aesthetically pleasing and appreciable, besides being, of course, safe and reliable, because the physical appearance is very important. For instance, in Japan, they've always designed robots to look like humans or like animals. Why is that? Because according to the Shintoism religion, They believe that humans, that machines, again Freudian, machines have a soul, and as such, the aspects to be accepted by the humans, the aspect must be of humanoid type or inspired by the animals. So the forms must follow the basic aesthetic criteria that underlie civil coexistence and human existence itself. And that is to say symmetry, harmony, and beauty. And there is a key role of design for robotic technologies to become part of everyday life by modifying them in responsible ways. Now, speaking about robots and humans, I just play a short video clip. This was one of the final outcome of my ERC Advanced grant, in which we developed a humanoid robot, which is called Rodiman. And besides using that against the benchmark of preparing a Napolitan pizza, I'm sure you have seen videos of the pizza-making robot in the media. There was everywhere. We also had Rodiman direct the orchestra on the beautiful scenario, on the settings of Villa Ruffolo in Ravello for the Ravello Festival. So this is a short video clip from the backstage in the lab, training the director of the pupils of the conservatory in Salerno. We use one of those sensorized jackets with accelerometers, inertial measurement units, sensors, and so we are acquiring the motion directly from the human. And once we do this, we have an avatar with the biomechanics data of the director, and we transform the motion, we acquire the motion, and we transform the motion through the avatar. And so this is the avatar. And he was really amused. He was really curious that that a robot will be able to replicate his fine motion. And this very much relates to a concept which was underlined this morning. This is the concept of cultural heritage. So we can use robots to learn directly from humans. And this is more than the data, more than the cloud of data, because it's the motion, it's the physical action, it's the sensory motor skills of the human. And here we go on the stage in Villa Ruffolo in the festival in July of 2019, yes, I believe. And Rodiman is conducting the orchestra of the pupils.
Bene, molto bene, grazie.
And the setting was just spectacular. I had goosebumps, when we had that performance. So the final point I'd like to touch upon is concerned with roboethics. Actually, there was a symposium which was organized in Villa Nobel in Sanremo in 2004. And we introduced this new concept in science, in robotic science, which is roboethics, which is not, of course, the ethics of the machines, because machines as such don't have ethics, but it's the ethics of those that design, that build, and utilize robots. And actually, now there is a branch of research in robotics which is identified with the English preposition else. Else stands for ethical, legal, societal, and economic issues for designing, constructing, and using robots. And so in this cohabitation of humans with robots, we should be very careful to analyze and to identify what are the fundamental human rights and the moral duties corresponding to them. And the final message I'd like to share with you is about of course, I am a techno-optimist, you realize that, and I have no fear of technology. But I do believe that we are moving towards a sort of renaissance, to a sort of technology humanism. This is an excerpt from the last paragraph of the lemma that I had the honor to write for our most authoritative dictionary, is the Treccani Encyclopedia. So this is the final, you can Google this, the whole lemma on internet. This is the so-called Atlante Treccani. So I'm reading verbatim. 100 years after the entry of the word robot into our lexicon from the novel of Karel Čapek in 1920, the challenge, at the same time the opportunity that the world of research will have to represent is related to future scenarios in which robotics will become an interactive means. So it's the sense of touch. I was shown the nice demo with the virtual reality that Alessandra was mentioning earlier, and actually I was visually immersed into the Stadio Maradona and then into the operating room with the Da Vinci system. That's the new challenge, because we will have to develop the possibility of transmitting tactile data, some sort of 5G enabled internet. And if we are able to do this and to compensate for the delay in communication, which is the latency, we'll be able to develop a new thing, the concept of Internet of Skills, as the natural evolution from the Internet of Things to the Internet of Skills. This is the so-called phygital twin, a digital twin immersed into a physical scenario. So we'll become an interactive means to help improve conditions of life. In this vision, the robot revolution will be able to help us reassert the least artificial feature of our world, our creativity, with the emotions, with the feeling, and in the very end, our natural intelligence, aka our humanity. Now, before concluding, just to give you a sort of overview of several applications of robotics. The videos are looping, so you can watch, the nine frames going. I mean, we can move from the natural concept, from the intuitiveness, from the plug and play option to operate a robot like in the upper left as a sort of tool, sharing the same workspace. This is what is called cobot in our field. Then it's the concept of autonomous car. I was in that car in the center of Parma with my friend and my colleague Alberto Broggi, who is now part of Albarella of Google, because his lab was bought by Mountain View, and it was remarkable to be in a car, just with kind of autonomous driving. Actually, if you go to San Francisco, you can take Uber robotaxi already in 2023. And then we have the application like, for instance, the surgical application. And the main challenge there is to enhance the surgeon perception with a tactile feeling. Actually, this year, it will be a challenging year up in the polyclinic, in the Icarus Center, because we will have the first millennials to start the training on robotic surgery. And that's a challenge, because the millennials, they were born in the age in the digital age. And we're not sure whether they will be able to use this technology in the same proactive fashion as the experienced surgeon who were used to operate using laparoscopy or using open surgery with a sense of touch. Now, the middle three are examples of wearable robots, say in the sense of endoskeletons, like prosthesis, like the hand in the middle, like the bionic hand, or maybe exoskeletons, like the suite that a person hit by stroke, this person is able to just walk. And this is also a kind of clinical use in hospital, where the nurses can just lift a heavy payload like a patient without feeling the weight. And then you probably have seen this kind of viral videos by Boston Dynamics. This is Atlas doing a sort of jobs assisting a human working maybe on a scaffolding. And the last three are just applications of field robotics. There's a case of a flying drone. Drones were used since a long time, were used for cinematography, were used like for inspection, but the new challenge is the possibility of achieving some aerial robotic manipulation. So it's the concept of having not only a flying eye, but also a flying hand, the manipulation, the hand, the touch. And the one in the middle bottom is an application of underwater technology. This is my colleague and I used to say, mon frère, my scientific brother, Usama Khatib from Stanford University, and the development of his Ocean 1K, who is a humanoid robot archaeologist. And he was able to operate the system at 1,000 depth, where a human cannot do any kind of manipulation. And the final one, I think has been stopped, but you probably saw this. I think this is Curiosity, which is the rover which was, and since we will have a message from our astronaut shortly, I think it's very relevant, and it shows the Curiosity is a rover with a robot manipulator that does some kind of sampling on the Martian soil. So the final message, what's up? This is not working any longer, so that's why. Can you advance? It got stuck. Il pitch is a block, okay, yeah. It's not my fault. Okay, that was the final message. It's like robots are with us, within us, and among us much more than you would think normally when you just have the etymology of the word just replacing humans. They are already with us, within us, and among us. Thanks very much indeed.